We're going to look at this movie theatre website, design a database for its features, and write the SQL to create the database. This site is for a cinema called Hoyts, which is a popular cinema here in Australia. What do we see? Other than this nice movie trailer playing, we see links on the site for movies, session times, and cinemas. We see a search bar, a login button, and if we scroll down, we see session times. Let's start with our diagram. I'll open a new diagram in my favourite diagramming tool, Lucidchart. You can use any other tool you prefer. Based on our very brief tour, it looks like the concept of a movie is pretty central to a movie theatre, so let's add a table for that. We'll call it Movie. What do we know about a movie? All we know at the moment is that it has a title, so let's add that. Let's go back to the website. We'll click on the Movies link on the left to see what else this website has for movies. We see some images for movies, and if we scroll down, we see even more movies. I'll open an individual movie to see what it shows us. Here is the page for the movie Inside Out 2. We've got the title in our database, so that's okay. We can see tickets on sale, which may be some kind of status or life cycle value. We can see this value of CTC, which means check the classification and is a kind of rating. There's this 105 minutes, which is the running time of the movie. We've got a date here, which I assume is the release date of the movie. If we scroll down a little, we can see a section that lets you book tickets, and the first date is the 13th of June, the same date as above. So yes, I think that is the release date. Back on the top, we have a link to a trailer, a description of the movie, and this text here, which is some kind of banner to encourage you to book a ticket. We've also got a header image at the top, this big image, and a smaller image which is like the official movie poster. That's a lot of things to store. Let's add them to our diagram. These things we saw can all be added as columns to the movie table. We should also add a primary key for this table, so we have a way to uniquely identify the movie. The status stores something like tickets on sale. The age rating is the CTC value. We may expand this if we see different ratings later. The rest of the fields are directly from the page. We have a booking section, which we'll come back to later. Below this, we have a synopsis tab, which has a longer description of the movie. We can add that to our table. We also have a details tab, so let's click on that. There are a range of attributes here for the movie. We've got a director, cast, genre, release date, and runtime. Both the release date and runtime are already in our table. What about the others? The director is shown here and could be added as an attribute of a movie. However, if we think about a director, they can exist independently of a movie. We may also see on other movies that a director can direct more than one movie. So we should add a separate director table with their name and link them to the movie table. The same thing can be done for cast. We add this director table and give it an ID as a primary key. We'll add in a column for the director name as well. Now we need to relate it to a movie so we can see who directed that movie. We do this by adding a director ID to the movie table as a foreign key. Our director table is set up. We can add a cast member table as well and do the same thing. But there could be more than one cast member for a movie, and there usually is. So we'll add the cast table, give it an ID and a name. We've got a many-to-many relationship because a cast member can be in multiple movies and a movie can have multiple cast members. So let's add a joining table. This is a common way to handle this many-to-many relationship. Let's see what else we need to add from the movie details. If you want to get a complete guide to this database design, including the final design diagram, a definition of the tables and columns, and the SQL statements, check out the link in the description. The last field we need to look at is the genres here. A list of genres is shown for this movie. It looks like these genres may exist separately from a movie, and many can apply. So we'll need to add another table for the list of genres, and a joining table to movies. We can now see these details for a movie. We've created a design. Now let's write some SQL to create the actual tables and then add some data. I'll write this in MySQL, but you can do this in any SQL database. We can create each of our tables using the create table statement. We'll start with the movie table. We add in the ID, the title, and the rest of the fields. I've chosen a few different data types for the fields. Some are integers such as the primary key. Others are text columns or varchar fields with a length that I think would be enough for the required values. We'll also specify a primary key for the table. Before we run this statement, we need to define the foreign keys for some of the fields to the other tables. However, the other tables don't exist yet, so let's create them first. We'll start with the director table. We can write this statement here. I'll add it above the movie table because the director table needs to exist before a movie can reference a director, and we generally run our statements from top to bottom. Then we can add the foreign key to the movie table for the director ID. Next, we create the cast member table using the fields from our database design. Then we have the movie cast table, which refers to both a movie and a cast record. We'll write this after the movie table because it has a foreign key to the movie table and that needs to exist first. Next, we can add the genre table. Then we add the movie genre table, which links to both movies and genres. We've now written the SQL statements to create all of the tables we've identified so far. Let's run them. We can see that they are all successful. If you get any errors, you can recreate the tables by running a drop table command first and then creating the tables. Let's insert some data next. What do we insert? We'll use the data for this movie we looked at, called Inside Out 2. We'll insert data in the same order that we created the tables, because if we try to insert records that refer to other records that don't exist, we'll get an error. So we start with the director table, and the only one we know of at the moment is Kelsey Mann. Next, we'll insert the genre records. After that, we can insert the cast member, and the only one we know so far is Amy Poehler. Now we can insert the record into the movie table. We've got all of the information here from the page on the website about the movie. We can run this query and the row is inserted. Next, we'll insert records for the movie cast and movie genre tables, now that we have the movie. These rows are simply the ID values for the relevant records for the movie. We can run these queries and the data is inserted. Our data is inserted for this movie. Let's see what it looks like. We can select from the movie table to see everything that's in that table. We have most of the attributes of the movie that we saw and the director ID. We can join to the director table and see the director name in this query. We can run it and see the results here. The web page can use the results of this query to display the information on the screen and load the images as shown here. Let's see how we can get data for these joining tables. We can join to the movie cast and cast tables to get the names of the cast members in this movie. We can run the query and see the results. It shows a single row with Amy Poehler's name here. What about genres? We can add these two tables into the query and add the genre name column to our query. We run this query and see our results, but our results are showing multiple rows. We don't want multiple rows though, we want a single row. The reason this shows many rows is because there are multiple genres for a movie, and each row is a different genre. There are a few ways we could handle this. We could leave it as it is and use the application to choose the first value for all fields except genre, but that's a bit messy. We could have a separate query for the genres for the movie, and this can work. However, there is another way. We can use a concept called string aggregation to combine multiple values into a single field. We can do this to combine all of the different genre values for this movie into a single, comma-separated list. This is how it's shown on the web page, and it would mean we only have a single query with a single result. Let's try that. The way to do this in each vendor is different, but in MySQL we use a function called group concat. We can use this query with the group concat function. It includes the column of genre name, which is what we are combining. Then we have a group by clause which will allow us to use this group concat function to aggregate the multiple genres into a single row. We can run this query and see our results here. We have a single row that shows all of the movie data. We can see the genre names here combined into a single list in a single field. However, there is only a comma separating the values, and it would look a little better if there was a comma and then a space. We can adjust our group concat function by adding in the word separator, then a comma and space in single quotes. We can run this query again and see our results, which show a comma and a space between each value. Excellent. Let's see what else this movie website has and then update our design. Back on the movie page, we scrolled past a section earlier about bookings. Let's look at that now. In this section, we can see under the heading the word Chadstone. What does this mean? I'll click on it and find out. A panel appears from the side called Select Cinemas. It shows a list of Australian states at the top, and within them, the cinemas that are available. The option of Chadstone is selected. So it looks like that Chadstone label on the main page is the selected cinema. This selection may impact the movie times and movies that are available. We haven't got anything like that in our database, so let's add it. We have the concept of a state and a list of cinemas, and each cinema belongs to a state. We'll add two tables, one for cinema and one for state. Each of them will have a primary key and a name, and we'll add the state ID to the cinema table so we can see which state that a cinema belongs to. How do we relate these to the rest of the database? We're not sure yet. I'm guessing it's related to movie somehow, but I think we'll find out more as we explore the website. Let's write some SQL to create these tables. We can write this statement to create the state table. Next, we can create the cinema table. We can run both of these statements and the tables are created. Let's insert some data. We can run each of these statements, which will first insert the state rows and then insert the cinemas. We can run these statements and the data is inserted. What does the data look like? We can write this select query that joins both tables and see the states and cinemas. We run this query and see the results here. Let's go back to our website. Under the selection of the cinema, we can see a few dates showing. We can then see a list of times during the day when this movie is showing. If we click on different dates, we can see the times change. Each of these times has different words underneath it, like extreme screen and daybeds. I'm not sure what this means, but we'll come back to that. Let's add the showing times and dates first. So we have the concept of a showing time, which is for a particular movie, and at a particular cinema. This is how the cinema relates to the rest of the database. Let's add a table for showing times. We'll have a primary key for the row. We have the date and time in a single field, which will allow us to filter the results to only show times for a certain date or date range. We also have foreign keys to the movie and cinema tables. Let's write the SQL for this. First, we create the showing time table with the columns we specified. We run this and the table is created. Next, we can insert some data. We'll insert these rows here, which cover the showing times for this movie at the cinema selected. We could add the times for all cinemas, but we'll keep it simple just for this example. We run these statements and the data is inserted. We can run this select query here that shows the times the movie is showing. We've filtered by the cinema ID and the movie ID, as that's like what the website would do, but we only have the one cinema and movie in our table so far. Alright, let's go back to the website. If you want to get a complete guide to this database design, including the final design diagram, a definition of the tables and columns, and the SQL statements, check out the link in the description. For the showing times, there are some terms underneath the times like extreme screen and daybeds. There are also some shorter terms like AD and CC. What do they mean? Maybe this legend button has some information. A panel appears on the right with what we're looking for. It has a list of terms and definitions, and there are different tabs with different items. How do we add this to our database? There are a couple of ways. We could add 3 separate tables, one for experience, one for accessibility, and one for attribute. We can then link each of these to the rest of our database. Another approach is to have one table with all of these attributes, and a field to indicate which of these 3 it is. Either approach can work, but the approach we'll take is the second one, having a single table of all of these attributes with a type column. This means we can adjust the types in the future quite easily. And we don't need to alter or create new tables for this. First, how do these attributes relate to what we see on the website? It looks like these attributes are different for each movie showing, and there can be many, so we can relate these to the showing time table. Let's do that now. We'll add a new lookup table to contain all of these attributes. This is a hard one to name. We shouldn't call it attribute, as I think that may be a reserved name. The term showing attribute may be something we use as the name of the joining table. Maybe feature? Let's call it feature. We'll give it an ID and a name. We'll also give it a description because they had a short description on the website. What about the type? I'll create a lookup table for the type. There are other ways this can be done, such as an enum or a check constraint. And if you want to learn more about why I recommend lookup tables, you can watch this video here. This table would have 3 rows: experience, accessibility, and attribute. We'll also add a foreign key from the feature table to this table. Let's create these tables. We can run these statements and the tables are created. Now we can populate them. First, we'll add the data to the feature type table. Next, we'll add the records to the feature table. This is the full list of features that are available. We can see the rows that have been added. Let's see the data. We can run this select query and see a list of all of the features and types in the database. The website can use this list to populate the legend panel that showed on the side. How do we relate this to a movie showing? Well, each showing had one or more of these features, and a feature can be applied to more than one showing. So we'll add a joining table for the showing feature. This can store all of the features for each showing. We can create this table by writing this create table statement with just these 2 columns. We run this statement and the table is created. To populate this table, we'll need to insert all of the features for each of the showings. I've created these statements to add the right features for each showing based on the website. We can run these statements and the rows are added. What does the select statement look like? Well, it depends on how the website wants to get the data. We could write this statement to find all of the features for a single showing. We filter on a showing ID and display all of the features and their types. We can run this and see the results here. Let's go back to the website. What happens if we click on a time? A panel appears on the right with information about our session. We can filter by different types of seats, such as daybed and standard. Then we can choose our seats in the cinema. It looks like a theatre has a range of seats, and each of them would have a unique seat number and one of these types. We can see the seats have different statuses based on this legend at the bottom: available, reserved, unavailable, and selected. There's also a small accessible icon on some of the seats as well. Let's add this to our diagram before we proceed. Let's start by adding the lookup tables. We'll add a table for the seat type, which can contain the standard or daybed values. How does this relate to the rest of the database? A movie showing has a range of seats in the theatre or the room where the movie is being shown. These seats have different IDs and are the things that are booked by a customer. So a showing time has many seats related to it. We're creating something like a booking where we select one or more seats for the movie showing. And these seats have different types. How do we add this to our diagram? We have an ID, the relationship to the seat type, and also the location, which is like J10 or B5. We'll also need a booking table, which is what we're starting to complete on the website, and this is how we relate the seat table to the showing time. For now, we just have a primary key and the ID of the showing time. What about seats? Well, we can book multiple seats at once, so we'll need a joining table. This will capture the seats that are included in the booking. It will also allow us to calculate the status of each seat. I think we have a problem here. We've got a booking that refers to a seat. This seat table will have maybe 100 rows, one for each seat. But we want to take bookings for many different movies, and also across many different cinemas. In our system, there are more than 100 seats that can be booked. We're missing something. In the real world, a seat is inside a theatre, or a room where the movie is shown. A theatre is located at a cinema, and a cinema can have one or more theatres. So I think we need to add those concepts to our diagram. We'll add a theatre table with an ID and perhaps a number so we can tell them apart. We also have a foreign key to the cinema table. Because the showing time is now linked to a theatre and the theatre belongs to a cinema, we don't need to have the cinema ID in the showing time table. So let's remove it. We can also add a foreign key to the theatre from the showing time table, because we need to know which theatre the movie is being shown in. The customer may not care when they book the tickets, but the website will need to know so it can determine which seats are available. Now we can relate seats to theatres. We add the theatre ID as a foreign key to the seat table. This means we can have hundreds of seats in our system and link them all to the correct theatre. I think that's all we need for now. Let's write our SQL. First, we create the seat type table. Next, we create the theatre table. We'll have to alter the showing time table to add the theatre ID and then add a foreign key constraint for it. Now we have this column, let's drop the cinema ID column. We try to drop this column, but we get an error. It happens because we have a foreign key constraint on this column. So let's remove the constraint. Then we can try to drop the column again. This time it has worked. Next, we create the seat table, which links to the seat type table and the theatre table. Now we can create the booking table. It only has a couple of columns for now. Finally, we'll create the booking seat table. Our tables are now created. We'll insert some data into some of these tables. First, the seat type, which only has a couple of records. Next, we insert some rows into the theatre table. Then we can insert into the seat table. We need to update the showing time table to record the theatre that each movie is in. We won't add anything to the booking or booking seat table yet, as we've just started that process. Let's go back to our website. We can click on the Proceed button and we'll see this page where we can select our tickets. There are a few different types of tickets we can select, such as adult, child, and student. Each of them has a different price. If we click Add, we can select the number of each type of ticket. I'll select some tickets. We can see a booking fee at the bottom as well. Before we click Proceed, let's add this ticket information to our diagram. We'll add a table called Ticket Type, which is our lookup table for the types of tickets. We have a name for the ticket type as well as a price. The price may change depending on different factors, so we may need to move this price. How does this relate to other tables? Well, for a booking, we have different types of tickets and different quantities. We can have more than one, so we'll need a joining table. We add the ticket type as a foreign key, which is a record like adult or child or student. The booking ID is the booking we are working on. We also have a quantity field, which is where we store the number of tickets of this type for this booking. Finally, we need to capture the booking fee, which is an attribute of the booking table. That's all we need for now. Let's add these to our database. We'll add the ticket type table, which is a lookup table. I've created the ticket price column as an int rather than a decimal, as I prefer to store money values as whole numbers. You can watch this video here to find out more about the benefits of this. We can create the booking ticket table to store the ticket types for each booking. Next, we can alter our booking table to add the booking fee column. Let's add some data. We can run these statements to insert some data into our tables: the ticket type, the booking, and the booking ticket. Our data is now added. We can click Proceed on our ticket page and see the next page, which will allow us to select some snacks. There are two categories of snacks, and each category has a range of items with an image and a price. If we click on an item, we can see more details and select a quantity. Let's add this to our design. We can add a snack table, which stores the available snacks, and the snack type, which in our example was either drinks or hot food. We can relate the snacks to the bookings by adding a joining table, because a booking can have many snacks, and a snack can be purchased in multiple bookings. Inside this table, we have the quantity field as well. We'll also need to add a name for the snack so we know what we are ordering. Alright, let's add the SQL for this. Here are the statements to create these tables. They match what we have in our database design. We can run them and the tables are created. We can insert rows into the snack type and the snack tables so they can be added to the bookings on the website. We can run these and our table is created. This select query here will show all of the details of the snacks, such as the price and the category. We can see the list of snacks here. Let's resume our booking on the website. On the website, we can click Checkout. We're asked for an email address, so I'll enter one and accept the terms. We can see the payment options below. We have a gift card and some other methods. We'll keep these details out of our database because it's risky to store payment details in our system, and we can assume we will use another provider for this. The next step is to select a method and pay. I won't do this in this demo, but we can assume there's a confirmation page and an email is sent. But we can add a couple of things to our database. For the booking, we can add the email address. We should also capture the date and time the booking was made. I'll call this created date time to be clear what it is. In our database, we'll have to write some alter table statements to change the booking table. We can run these and the tables are updated. What's next? Let's look at another movie on the website and just check if anything is different. We'll select this movie called The Strangers. We've got this label here of now showing, which we captured in our database already. However, we captured this as a varchar field on the movie. Now that we have more than one status, we should have a lookup table. We can then rename this status field to status ID and make it a foreign key. We've got fields for the images and description already. We can scroll down and see the details. We have multiple cast members, a rating, and a genre. It all can be covered by our database so far. Let's choose a date and time. We can see the seat selection here. It all looks good so far. I won't go through the whole thing, but the purpose of this is to see if anything we have captured in our database design needs to change. Let's look at the cinemas. We can see a list of cinemas here in the company. We can see the cinemas grouped by state, which we have already captured. There are different attributes for each cinema here, which looks familiar. Let's open a cinema. We can see more details about this cinema here. It has an address, which is helpful. We can scroll down and see all of the showing times for all movies on specific days. I believe our database has this already. So it seems our database design has covered what we have seen so far. Here is the final design of the database. If you want to get the diagram of this database, as well as the full SQL scripts to create and populate the tables in this database, and an explanation of each of these tables and columns, check out the link in the description. What else could we add to this design? We could look into the events and festivals section and see what that includes. There's a login button on the top right which implies some kind of account creation. So there are several things that can be added. You can follow the same process that we did if you want to add more functionality to this design. This movie booking design turned out quite complex. Another complex database design is the products and attributes for an e-commerce website, so you'll want to watch this video next to see how I did that using a real e-commerce website. Thanks for watching.